Hello everyone, my name is Angelos and today I'm going to be showing you how to back up your StorageOS volumes using Valero. First, let's see what kind of cluster we have our hands on today. By doing a get nodes, you can see that we have one master node and 3 worker nodes that are running on AWS. And then by doing a get pods, we can see that this is a rancher provision cluster that has StorageOS running on it already. And we can also see that Valero is already set up. One thing to note is that we're going to be using Minio as the backup object store that's going to be running inside the cluster. Now, this is not actually the recommended way of running Minio. I think it's better to run it in another cluster so that you can reduce the blast radius in case of an outage in this cluster. So if you want to use Valero for your backups, the first thing you need to do is actually set up Minio, which as you can see I've already done. But it's a really simple process. What you need to do is just run this manifest file, which includes a service account, a namespace, a stateful set, which is pretty standard, but some things to note is actually the Minio access key and Minio secret key. These two values are going to be using for Minio to be able to authenticate with the rest of the cluster. Another thing to note is also that we're using a volume claim template with a StorageOS replicated storage class, which is a StorageOS storage class with one replica. So we can see that we're actually provisioning storage using StorageOS for Minio. There's also 2 services, one node port and one cluster IP. The node port is there so we can access the web UI, and the cluster IP is there for Minio to be communicating with the rest of the cluster. And there's also a job that does some miscellaneous configuration and creating the Valero bucket. I've already run this, so we can actually see it running on the browser, on the web UI. Here, as you can see, the cluster is pretty much empty. It only has this restic from a previous backup I was doing earlier. But soon we'll be able to populate it with more stuff. The next thing to do is actually install Valero inside the cluster. This can be done with 2 ways. One way is using Helm chart. The other way is using the Valero CLI. In this case, I just used the Valero CLI since it was a bit simpler. The way you do it is you just run this install command. One thing to note is actually the S3 URL should be where your Minio pod is located. In this case, because we're running inside the cluster, we can just use the service Minio on the 9000 port. And another thing to note is the use restic flag needs to be there. This enables the restic daemon set to be set up in the cluster. Restic is really essential in this case because it is what is going to be backing up the volumes themselves. So here I have Valero already set up in this cluster, so I don't really need to run this command. The next step is to actually run 2 demos of showing the functionality of Valero onto real-life applications. In this case, I have a Debian pod, which is a very simple pod running Debian and just doing a sleep command. Here, what I'm going to be doing is I'm going to be running an exec command on the actual mount point of the volume, which is /mount, and I'm going to creating a hello world file that's called hello inside it. So I'm going to be doing that using the kubectl exec. And we can actually see if we can actually cut the file to make sure that this there. It's great. So now I can do a Valero backup create command. So what this is going to do is actually going to create the backup and send all those files to the cloud to Minio. In this case, I'm going to be using the include namespace selector, but you can use other selectors like labels or stuff like that. So the wait command is just waiting for this to be done. Okay, that was fast. We can describe the backup to make sure that everything is there. We're gonna add the details flag, which is gonna show us more details about what was backed up. Here we can see that we got all the events backed up. We also got the namespace, the persistent volume, the PVC, the pod, the secret, and the service account. And we can also see that the restic backup is also completed successfully. So that's great, that means this worked well. Next step is to actually delete the pod. So here, as you see, delete pod D1, Debian. So while waiting for this pod to be deleted, I want to show you the actual manifest of the pod. So here you can see it has a namespace. It has a PVC of the storage class name fast of 1 GB. So this is also provisioned using StorageOS. And then the pod is getting the PVC, mounting it, and mounting at the /mount directory as I showed earlier. Another important thing to note is actually the backup Velero .io backup volume annotation, which actually shows which annotation you would want to back up. Valero is actually an opt-in, it's set up in an opt-in kind of way, so you need to opt in which volumes you want to back up. Let's see if it's actually being done. Okay, it's been deleted. We can actually delete the PVC now. Yep, it's deleted. Let's see, is it actually running? Nothing here. Nothing here. That's great. So now we're going to be doing a Velero restore. Again, we're going to do restore create from backup and then the name of the backup, which is D1, and then the wait command for the wait to be finished. While this is running, we can actually see the files that have been backed up. So if I do a refresh, here you can see the D1 backup being here. This is all the tarballs of all the Kubernetes objects that we're using. And then in the restic, you can see the namespace Debian there, and you can actually see the data that was they're actually set up as blob files, that are actually stored as blob files. Yeah, while waiting for this to finish, yeah, these are all stored as blob files. It also has the index, the keys, and snapshot, which in this case is a snapshot of that volume. Now that should be done. Yep, that's great. So we can actually describe that restore. Yeah, completed. Now let's see, is it actually there? Okay, pods, it is there, cool. Okay, PVC, it is there, amazing. So next thing to do is actually running the cat command to see if the file is there too, and great, the file is actually here too. So the backup was done correctly. The next real-life application we're going to be using is using a MySQL application, which is already running on the cluster. As you can see here, we have a client and we have a MySQL database running. Let me actually run some commands on the MySQL database. Was the wrong namespace? Great. So now we're accessing the MySQL database, and we're going to be running the following commands. We're going to create a database called shop. We're going to be using that shop. We're going to create a table called books, and then the table we're going to add the book Gates of Fire. A great book, by the way. So now it is there. Actually, let's actually see it being there as well. So if we do MySQL use shop, select start from books, yep, we can actually see it being populated. It's great. Next step is to actually do the backup. So we're going to use again Velero backup create, and we'll call it MySQL1, and it's going to be the namespace MySQL, again with the wait command. Now there's a bit more data to be copied there. So let's see it. Let's do the details. Yep, we can see that everything has been set up and backed up, and we can see the restic backup is there too. Next step is to actually delete the stateful set. So now, while we're waiting for the MySQL pod to be terminated, we can actually have a look at the manifest files. So in this case, we have a namespace called MySQL, a service account, a service, a config map, and then the stateful set. And this is where the important things are. Again, as you see, we have the backup volume called data, and here again a volume claim template of data. This time we're going to be using StorageOS replicated, so this is actually an example where we do have one replica. Another thing that you probably noticed is that we have this pre and post hooks, post hook commands. So what these do is that you can actually run commands before and after the backup. As some of you may know, if you try to create a backup without doing any sort of QS, which is freezing the database or the file system in some way, there's a very high chance that you're going to get corrupted data just from I/O that is in transit or is going to happen while you're doing the backup. So it's a good idea to have some sort of QS in place before the backup and then unfreezing it after the backup. Thankfully, Valero allows you to do that. In this case, we're going to be using an FS freeze, which is not the best QS, but this is the one that is recommended by Valero. Hopefully in the future there's going to be more complicated QSs, like using the actual MySQL one, which would be flashing the tables and adding a read log. But this is still a very experimental command, so for now we're just recommending doing an FS freeze or doing a QS of outside the Valero backup, the Valero pre and post hooks. Yes, so the way the QS works is that you have a pre-hook that has the command in a comma-separated list, and then we have the container that this is going to be running on. In this case, we have added an FS freeze Ubuntu container that actually allows the functionality of FS freeze because MySQL doesn't. That also has the same mount path as the MySQL one, so it freezes the file system there. Let's see if the backup has actually finished. If the delete has actually finished, so if we do a get pods MySQL, yep, it has deleted the MySQL pod. So if we delete the PVC as well, okay, delete PVC. Awesome. So as you can see here, no PVC. No, and just a client pod, but the MySQL pod is what matters in this case. So we have created the backup. The next step is to actually restore from the backup. So again, Valero restore create from backup, and let me remind me what we actually use the name of it. The name is MySQL one. So this is going to be restoring everything. While waiting for this to be restored, I'd like to talk to you a bit more about how backups and restores are happening in Valero. So Valero is actually using an operator or controller paradigm. What happens is the user creates a custom resource using the Valero CLI, which goes to the Kubernetes API, and then the backup controller is actually watching the Kubernetes API, and if it notices that object, it queries the Kubernetes API of all the Kubernetes cluster resources and then uploads all of them to the cloud provider, which in this case it's Minio. For volumes, it uses restic to copy all the files to the restic directory of the cloud provider, Minio in this case. After all those backups are in the cloud provider, the way Valero restore works is it actually checks if a resource exists. And if it does exist, it does nothing. So when you do Valero restore, it's not going to override already existing resources. If it doesn't exist, then it checks if that resource includes a volume, which you can actually put an annotation on that pod. And if it does, and if it doesn't, then you just create the backup. If it does, then you create the backup using the manifest, but you also add an init container, which actually copies the files from the cloud provider to the mount point using restic. So it's quite a simple process. As we can see here, the restore has actually worked. So let's see if it completed successfully. The restic restore has also worked. That's amazing. So if we check the pods, we can see MySQL is running. Let's see if it actually has all those new things that we have added onto the database. So we can see the shop database is still there, which is great. So if we do select star from books, yep, get so far is still there, which means the restore happened successfully.
We hope that you enjoyed and found the demonstration useful. All the examples that we used are available in the use cases GitHub repository. You can check the documentation on how to install the StorageOS as well in docs.storageos.com. And finally, you can play with the StorageOS in a virtual installation at play.storageos.com. Now we're gonna pass to the Q&A if there are some questions from you guys, and let's see we can find some answers and shed some light.
Thanks, Fran. Yes, we do have a couple of questions. So first up, what are the advantages of backing up using Valero against backing up my underlying VMs using snapshot techniques?
Mm-hmm. Yeah, that's actually a good question and quite a common one. First, I would say to be really careful, and I cannot emphasize this enough, when you back up the underlying disks themselves with snapshot technology or what we would call a binary backup. It's very easy to have a non-sync copy of the data in disk. The operating system have many caches, the application have caches, devices have caches, and it's dangerous to do one of those snapshots without flashing all this data before executing that kind of copy. So today we showed a bit of the QoS or the fact that we can execute a file system freeze before executing a backup. However, I would say that if you use anything like backing up backend disks, be really careful about the consistency of the data. So I would go either to application backups, so use the tool that the applications have, or have a technology that allows you to do some sort of control over the persistence of the data. Otherwise, it's very easy to just back up things that are not recoverable. You will have backups that are many gigabytes available or many gigabytes of capacity, yet they're not recoverable because the file system are either corrupted or the files are broken and not in sync. Mainly for databases. Stateful workloads are very sensitive to these kind of issues. So be careful and make sure that actually you have persistent, the data consistent.
Brilliant, thank you. Next question. StorageOS lists several backup techniques amongst their use cases. Should I use application level backups, sidecar techniques like Nginx or rsyncd, or Valero, or all three?
I would say that this is the fast or the short answer is it depends. I think both solutions are both solutions or the three solutions are all good. However, I could distinguish between the needs of your team and the needs of the development team, and actually how philosophically you see disaster recovery and backups. Why I'm saying that? Because if you think how Valero works, you have a lot of automation that is done for you. You just have to tell your Kubernetes cluster a schedule, and that schedule will just enforce backups and you can restore easily. And when you need to restore, actually from a disaster recovery point of view, it's very easy, it's very fast. And you just need to trigger that behavior. On the other hand, you also have to have an object store based backend to store those backups. But you have to install it once and the maintenance is actually quite low. And you also can use cloud providers for object store like S3 or Google Object Store, and you don't have to maintain it. That will serve very well for applications when you have multiple kind of applications, so you don't have to worry too much about which kind of backup each application has. So it's a one solution fits all. If your team is not really big and you want something that automated, yeah, Valero is a great tool. On the other hand, you may want specific backups, which actually are also very good solution for every database. Every workload or every stateful workload have a different way of backing up, and usually has its own. And that those tools know if, for instance, you need to block input-output operations or snapshots, or it needs to reconvene certain information across distributed systems, for instance, metadata. So I would say that all these solutions are good, and I would say choose the one that fits better for your use case and for your teams.
That's good advice. Thank you very much. All right. And with that in mind, that's the last of our questions. So I'd like to thank everybody for attending, and see you next time.
Thank you. Bye.